So you'd say secret technology, you're talking the microphone is connected there or something.
Okay.
But yeah,
Okay. Yeah, apologies for the recorded stuff. But yeah, we're talking about the YOLO model. Um, so yeah, since it's uses single pass detection, it's really great for um real-time detection because it's gonna go super fast. And it also works on many different devices, which is what makes it, such a popular model. Okay, so we can get into the collab now. This is a thing. Now we're not gonna do like a ton of coding on the in the collab. I just kind of want to give you guys a high level, and then like we can have some fun with whatever it spits out. Okay. Okay. So I'll leave this up here. So is everyone on the collab, or everyone who wants to be on the collab on the collab? Okay, I mean it's pretty short. Let me know if you like lose the collab. It's just quite a simple hyperlink. Yeah, so the first thing we're gonna do is pip install Ultralytics. Most of the stuff is already on here, but Ultralytics is, what's behind the YOLO models. So that's why we're doing the pip install for that. I kind of want to take it in a couple steps so everyone kind of understands what's going on. And the way I'm going to do that is first, we're just going to do bounding boxes with single images. So we're just going to access my webcam and then we'll capture an image of myself and then we'll let YOLO work on that to detect it. And then we're kind of just going to extend that to real-time video by making it take multiple images, multiple snapshots, and then just keep replaying those new ones and replacing the old ones with the new ones. So it kind of gives you that illusion of uh, real-time object detection. Uh, there's probably a way to do it much faster, and the most optimal way to do it is probably not on Google Colab, but this is what we try to do so that it makes it a bit easier for the presentation. So the model also might be a little bit slow, like the actual inference time should be fairly fast, but the FPS will be fairly slow. So yeah, is if everyone on the Colab, I'll just start. Here's are just our basic imports. We used, IPython. We're using CV2, which I think we've gone over in the previous workshops. Um, and yeah, from Ultralytics, we're importing YOLO. Uh, More specifically, since I mentioned we were using YOLO V8, actually, I'll get into that in a minute. I'll just run these so that it should be fairly fast to run. I don't think it'll take too long. Here, what we're doing is this is a function to access your webcam. To make it actually work on Google Colab, you actually don't write it in Python. I found it online that the best way to do that is to use JavaScript. So there's like a ton of JavaScript here. Kevin actually got confused as to why I was using JavaScript randomly, but yeah, that's why we're using it here. So I'm not gonna go over that because we've done absolutely no JavaScript in all of AI school. But when you want to actually work with YOLO in the future, you probably won't need to write like a whole JavaScript program. You can just kind of do it in a much faster way and much more efficient way. And then this is one of these functions is to kind of convert what JavaScript did back into the OpenCV format. Um, so again, I won't go into that because that's JS. Um, but yeah, this is the detection function. It's again quite straightforward. You're using CV2 to do most of that, and then the model we're initializing that to YOLO V8N. So V8N is the N stands for nano, I believe, and there's a couple different ones that we were trying. So V8X, V8S, and V8N, and uh, we're gonna do it on V8N because that's the smallest of them. So the inference time will be a lot faster compared to V8X or V8S. So I mean, yes, we can run that again. And then now we're gonna, what I've written here, we're gonna run our capture webcam photo function. So that's the one that uses JavaScript to access your webcam and the images for processing. And then what's gonna pop up is I'll just run it, show you. I don't know. Explain. Oh, okay. Um, you might have to allow for the permissions. I'll just run it again. Okay. Yeah. So yeah. So now it's oh okay. Yeah, sure. I'll zoom in a little bit, but you should see that my computer's lagging. Okay. So yeah, that's my face. Uh wait, let me get down. Uh it's kind of flipped me, so I look way worse. I actually look a lot better usually. But okay, so this is kind of boring that I'm just holding a mic and it's just me. But maybe there's a couple. If anyone has like some interesting object that you'd like for me to hold or put in frame, then uh I can do that.
Can you hold my phone?
I could. Sure.
Yeah.
Yes. Actually, I have my own phone. I don't know
Oh,
why.
yeah.
It's fine. Okay, fine. I'm just gonna hold it. So hopefully it recognize. Can you press capture image for me? Okay, I think the capture image is below somewhere.
Yeah. Above.
Oh, did we not click it? Let's do it again. Okay. Okay, awesome. So it didn't do everything amazingly well. Hello. Yeah, it didn't do everything amazingly well. It called my mic a bottle. But at least it called it a bottle with less confidence. I had only like 27% confidence for that. The cell phone was pretty good. It also recognized the people in the photo in the what's on this side in the back, which is kind of cool. And I think it even had a bounding box around Rebecca's hand and identified that as a person. So I think one thing I've learned is it's really good at detecting people. Um, I think this is also something that's used in security systems at times, or at least in movies. Uh, but yeah, that's pretty cool. I want to try putting like my charger. Or actually, can I use your actual bottle?
Yeah.
Yeah. Okay, I'm putting this mic down. I hope all of you can hear me still. Uh, okay. Let me just capture an image again. This is kind of complicated. Okay. I don't know if it. Oh wait, my bad. Okay. Okay, it did not recognize anything. So that's kind of sad. But maybe it's because I kind of mixed everything and I kind of got mixed up with my bounding box and everything. Like I said, the single pass detection is not as strong as like a multi-pass detection. But still with more objects and perhaps a more complicated image, it might do a good job as well. So basically we're gonna do this, but we're just gonna extend it so that every frame uh it's constantly having these frames every second if possible, if not more. So maybe like a couple frames a second if possible. I know that like most, like at least animated movies generally tend to keep a minimum of about 24 FPS. So that would be kind of ideal to at least keep some sort of image detection. But I think there's some sort of issue with me doing it on Colab, because we checked the inference time as well, which was quite good. But yeah, hopefully when you guys implement this yourselves in the future on your own laptops or in a different environment, I've heard people use like Anaconda as well. It becomes much faster and much more smooth. So I'll just these are kind of all the same things again. I don't know why I'm rerunning it. Um, but oh, it's glitched up. One second. Yeah. So that's kind of dumb of me to rerun it, but I'm gonna do it just because I find it more satisfying this way. Um, and you can kind of take these pieces. There's a couple of small changes in them. Um, but yeah, here it's again the exact same code pretty much. But the only difference now is that when I run the next part, it's again, this is not AI, this is just regular coding where it's gonna produce a bunch of images instead of a single image. So it should already have access to my camera. And I think it's already started. It's doing it as a bunch of images, but if you just look at the top image, it, oh wait, the bottom image. Yes, somewhere around here. I'll kind of, yeah. So as I'm like, okay, yeah, somewhere around here is a good place to, yeah. Okay, it's not the most smooth thing ever, but as I'm moving things around, it's able to detect them. Uh, it kind of looked at my, okay, I think a charger is not a great thing to use. I'll try to use the bottle again this time. Or okay, it's doing it much like faster. Again, like I said, this is not like anything super different from the thing I just did. It's just capturing a bunch of images one by one, but just like at a much faster rate and doing it. Okay, it actually got bottle this time, which I think is a good sign. Uh, if anyone else wants to come in frame, they could do that as well.
It just disappeared.
Let's go. That's two
Works.
people. That's two people.
That's one.
So we could try the pizza as well. Yeah, come. Okay. I kind of want to try the pizza. 1 second. Can you bring your pizza over here and put it in the flame? Oh, that's actually a good idea. Oh, I got the chair when I got up.
It
but-
is not detecting
Oh, it
filtering.
has a
No,
remote?
It is not a remote.
I
But
don't.
maybe if it's close in.
Um, okay. It's. I think it's kind of identifying it as a person in one of the shots there. But that's quite good. Yeah, that's actually really. It is eerily good at detecting pizza for some reason. Um, yeah. So I think yeah, if you can also see like the weights and the stuff that it's kind of trained on online as well. If you go to like your V8 something, I can like add the link later. But okay, it's thinks of this as a bottle for some reason, but okay, it's not helping. Yeah, okay, it's not helping. Um, maybe it's not trained on microphones, but okay, I got it. But yeah, it's trained on a bunch of very basic objects, so it might have more difficulty with complex objects, but you could always use YOLO on more specific items. So one thing that I've used it on in the past is to detect signatures in documents. So it's able to detect where a signature is in a document and then put a bounding box around it to extract the signature. So that could be useful for many different things. So we used it for like a signature extractor. We actually did it as a part of ACM projects. Another thing we've used it for is like as a kitchen assistant. It was able to kind of identify different kinds of um, kitchen objects, like different kinds of knives, different kinds of forks. So you can kind of do it any way you want if you have the right data set. But yeah, there has a lot of potential in that way. I'm sure you guys, just like while I'm speaking about it, have already thought of many ideas of how you can implement this. But yeah, that's why we just showed it to you today because it's more about, since it's the last workshop, it's more about kind of showing you something a little bit cool rather than just going back in theory again. And wait, who's Anya's next? Yeah, and Anya's kind of gonna continue on that path by showing you how to deploy, um, some sort of AI model, online, and then yeah, pass it to her. You want to do it on this laptop? Your laptop? Okay, sure. I'll stop this.
Yeah. Do you think that's? Oh yeah, I think I think it hears me. So awesome. So yeah, we'll talk about how do we go from Google Colab kind of to actual web application that other people can use without having access to your code and all of those technical things. It will be like a very like first step in doing so. I feel like what I'm about to show is has a lot of ways you can develop that or build your own stuff on top of it. But I just wanted to show the basics of how you would go about it, and it's totally not like the only way you can do it. Also, there are like a lot of different ways. And we will deploy an AI model that we built last workshop, which was a CNN model on our CFAR dataset. So I put the updated slides. There's like literally just one extra line of code in that link. Yeah, let's look at that. So this is just the collab from last week. If you have it and if you modified it before, that's awesome. Maybe yours is more accurate than mine. But yeah, the only thing I added over here is this part. I'm probably gonna make it bigger 1 second. Yeah, is this part. And what it's doing is, as you remember from last time, this is the code we used to train our model on the dataset. And straight up after the training, what I'm doing is I'm saving those parameters that, yeah, I'm saving those parameters my that was a result of my training into an extra file. And you can find the files over here in this tab. So this is files, and then torch save, simple CNN model, and this is your binary file that is saving now the weight of your model, so that we can use that file and take this model anywhere we kind of want. So yeah, as I said, you feel free to use your own like AI model or your own code from AI School 3 just by adding this line as well right after training. If you were not here or if you want to start over, you could just use this Google Colab link. Yeah, and then now we're going to talk about how do we actually put it on the web? Like how do we make it like an application? For that, we'll be using a Python framework called Streamlit IO. You can go here. Essentially, this is a very cool application that allows us to just write Python code and it creates a web page for us without us needing to know all of this complicated, very daunting web stuff. So you can sign up. I will sign in because I've already done that. Yep. Oh, this is the wrong tab. Yeah. For here, when you're like creating an account, you have a choice of like signing in with Google, signing in with GitHub. If you sign in with GitHub, you can straight up just go into like there is this menu, My Apps, and there's Create App. And here you have three options. If you connected your GitHub to it, you can straight up just choose a repo where all of your source code is, which we will show later. And you straight up can deploy your web application straight from here. If you're not connecting your GitHub to it, I believe you would just have your repo public and you can also use it anyway. Also, just a side note that it is not like a prerequisite for this workshop to know GitHub or like have a VS Code that I'm going to show later. But it's just like an overview, and I think that's something, if you're just starting out, it's something that you will encounter at some point. But yeah, general overview of what we're trying to do is we have our collab with our AI model. We save the weights, all of the stuff that is determined by our training. So we don't have to redo the training every single time. And then we build an app that uses those weights that we got from training to do some cool stuff on the web. But yeah, um, I I have created like using this window. I have created an app. I think it's linked on the slides over here. Example GitHub repo, and this is my repo that I've created with the. This is like yeah. This is all you need basically to run your own web app with Streamlit. there's a requirement.txt. It's all of the requirements that you need to install, like all of the packages and libraries, but you need to install before you're able to run your program, which is basically just Streamlit, Torch for our AI stuff, and Pillow is an image library. Yeah, then this is simple CNN model.pth is the file that saves our weights that I created through that Google Colab that I just showed. And then app.py is like our source code that Streamlit uses to actually run our program. And I will show what it means. So basically, I just copied the architecture of the model straight up from the Colab. And then I used this file with weights to load in the model that was trained back in my Google Colab. And now my goal is that now I have my model in this code space. Now I want to be able to upload an image, and then for that model to classify that image like on the web, so the user doesn't have to interact with a lot of code on Colab. So we're assuming that the user will upload some kind of image, and because of that, we need to define a transform because it's important that our model um, that the images that come in into our model are or the correct size and range that our model takes. This is like Streamlit title and Streamlit write are those pretty awesome commands that are used to pretty straightforwardly render something on the web without you knowing like some HTML language or something like that. Then file uploader, this is a line that will help us get the image as an input from the user. And then if we got our image, we just open it using our pillow library and then put it through our model. And then we can display the predictions of our model. So yeah, that's basically all there is to the source code of this. And then you just give Streamlit like the link to this repo kind of, and you're able to deploy it on the web. And after you have done those steps that it asks you to go through over here when you create a new app, I've deployed it over here. You can just click on the app link. And yeah, this is a public application that people can use. We can just try it out. Like browse files. Let's say I want to try and see how it does on image that we kind of saw before. So let me just take that screenshot, this awesome automobile, and see what it says about it. Yeah, we can see that the upload was successful. It displays our image over here. And then we also see those fields. So it predicted correctly that it was an automobile. We also have the confidence value and top three predictions. We also kind of can see what else is kind of considered of being close, like truck and ship. Let's try something of the web. Where say let's try a cat, like a random image of a cat. This looks like a good cat. You can take a screenshot and then, oh yeah, this is not the right one. Yeah, and now we uploaded our cat. And then for some reason it predicted a dog, which I'm not sure why, but we can see that the second kind of most probable option was a cat. So it's not that bad. Yeah, it's not that bad. So this is pretty fun. And the other thing I wanted to show is, yeah, it's kind of more of a technicality of how do you like tweak those program that I just showed you, and how would you run it on your own. And I will show you how to do that as well. Again, if you're not familiar with like GitHub or VS Code or stuff that I'm showing, I don't think it's that important. The most important is just like to understand like the overview of what's being done. Okay, just quickly show how you can modify this code. So if you want to use this as a base, you would normally fork that to create your own copy of that repo. I would just say fork. Can I do that? I think I can do the fork just because I already own this repo. But yeah, you would normally just do fork, and this would create a copy of this workspace on your own local computer, which is what we want. And then you would see a screen similar to this one, and you would go to code, and then copy this URL to clipboard, and then you can open, and then we go here to terminal, new terminal, and then we can git clone into that. The git clone just means that it takes that repo or that code of web of GitHub and puts it in a physical directory on your local computer, which is what we want to. Oh yeah, I did that before. So let's do let's do let's remove that real quick. Oh, I can't do that. Never mind. It would, yeah, that would normally work on your part just because you don't have a directory with the same exact name. I just have it because I tried this demo before the workshop. So yeah, now I should be able to git clone. So I did git clone, that link that we just copied. And then this is installing that code that I just showed you on my local computer. So now what we can do is go inside of that. This is weird. Go inside of the directory using change directory command. AI school 4. And then we would open a code, like some kind of code editor. I just prefer VS Code. So we will open in VS Code. Yeah, and now we can see all that code. I trust the authors. And here we can see like all the same things that I showed you just right now. But right now you can actually edit it and do stuff with it. And to build your program off of here, before you put it on the web, you probably would want to test it out on your local. So you would do the new terminal. Then I put it in README. You would need to do pip install the requirements. I hope I have them all because I did that before. Yeah, so this installs all the rel libraries that we need to do to have to run the command. And then the main command is run in our source code file. Yeah, so it seems like I do have all the dependencies. So we'll just do this. And this opens a local version of that app, which is not on the web yet, but it allows us to test it out before we actually put it up publicly on the web. Yeah, so it's basically the same thing. Yeah, I think that's basically it for this quick demo. Please let me know if you have any questions at any point of time during the workshop or after the workshop. Yeah.
Cool. Let's go next.
Yeah.
So what else could we do with AI?
Can everyone hear me? Could you check if like the Zoom is working?
Yeah.
Oh, hello. Okay. Yeah, nice. Okay, so thank you everyone for coming to AI School. So right now we're gonna like talk about some like current trends in AI and like some current considerations that you can look into. So here's like a brief history of like for computer vision. This is for AI School this time we're talking about computer vision. So you can see there's a lot of like evolution of all the topics. So here's like a clear view of like what the current trend is. So as you can see here, like the most recent change here is that we are changing from something called deep learning into like a combination of vision and language. So you probably would know like what the language here means if you like recognize any of the brands here or like the companies here. So yeah. So I guess before I jump into like vision and language, first of all, like for computer vision itself, it's highly related to other fields. So if you look at like the slides here, you can see it's overlapping with like machine learning, natural language processing, like and a lot of like other STEM fields such as neuroscience or like physics. So for example, like there were like three Nobel Prize winner recently in like physics and chemistry that are all like AI researchers. So this is definitely like the most exciting time for you to like step into this field. Yeah. So regarding to like right now, since we're all using like large language models, so from like OpenAI, Anthropics, and then like Google Gemini, there are a lot of like ethical considerations that we should be looking into. So since large language models are being trained on training data, and the training data are gotten from like internet. So usually they would usually represent like the data that it was being trained on. So that also means that it would probably reflect like a lot of the social issues we have within like how we talk about things. So the first thing probably would be biases. So you can probably experiment around with like how large language models will be replying to like different kinds of scenarios. So if we are using large language models to make decisions, how do we like mitigate like the biases it will be having when it's being like when it learned from us when we already ourselves have biases. So that's one thing to consider about. And then apart from that, there's also an interesting talk about generative AI. So here, so a lot of people, I think you've been using like Stability AI to generate like interesting piping. But another thing is since in the training data, there are a lot of like the data that from like actual artists, like from modern artists. So how do we mitigate with like the copyright issues within generative AI? So for example, how do we like prevent the generative AI from generating that character who should not be named? Yeah, so currently like one of the example for what people are doing, feel free to look at like the source. So one of the thing they were doing is called concept ablation. So it's kind of just like a harder way to say removing concept. So for example, they are trying to remove like the style from Van Gogh or like remove like the grumpy cat, like the actual cat from being generated when you are asking generative AI to generate grumpy cat. And this is because you necessarily don't want like, for example, if you are like a celebrity, you don't want people to use like, since you are like wide known on like internet, so you won't want people to use like to be able to generate your picture from like the generative AI model. So these are some interesting research directions. And then other than that, there's also some interesting overlap with like vision and language and with how like widespread it could be used for. So for example, in autonomous like cars, we sometimes like right now people are trying to explore with like planning and like driving using large language models and seeing how we can use like the wide knowledge base that large language models have with text to like actual driving. And then the thing on the right is called segment anything. So it's from Meta AI. So this is like an example of like instant segmentation. And then with this model, it has already achieved like it's able to segment like literally anything. So it's no longer like what we usually thought in like, for example, intro to computer vision class, that we have to like do a lot of specific class training to do instant segmentation. So right now there are a lot of models that are able to be like more like a generalist and like they are able to perform multiple tasks. Yeah. And then and then here's also another biases in terms of generative AI. So yeah, these are some considerations for you to look at. Yeah. Oh, and then sorry for the and then a few other like interesting direction is in terms of robotics. So right now people are also using like large language models with robotics, and also there are like something with like reinforcement learning that you should look into. So here are like some kind of like robotics, like human robotics and robot interaction, and with how robots can be used in like manufacturing. So on the left is with like human drawing together with like robots. And on the right, if you know about some like startup companies, on the right is like the figure robot. And right now they are that is a use case BMW is using figure robots for within like car manufacturing. Yeah. So I feel like for me, I feel like this is no longer like a distant future for us right now, where like robots might replace us for some like lower level task. Yeah. So does anyone have any questions so far? Okay. Yeah. So for people who are interested in like learning more about like all the current trends or like learn more about the fundamentals, I've listed some like resources for you to look into. So feel free to go onto our slides and then click into the resource. Yeah.
And then thank you for coming to the AI School series. This should be everything that we covered for the ACM AI School series in the fall of 2024. So congratulations. Either you got into the ones before, you've been through with us for everything. Like congrats for being at least at one workshop. So yeah, cool. So I guess if you guys have any questions or stuff, you can contact us through those ways. But next quarter we have like more fun workshops coming up. They'll be on a very diverse field of topics in AI. Like because for this quarter we really focus on computer vision. But for the next quarter, what we will be covering is more on like some of the hot topics that come up, such as natural language processing. So for that workshop, might be like LLM and stuff, recommender systems, how do we like do reinforcement learning on a robot, and also how there's like some newer frameworks in AI that like basically accelerate your training by 100 times. Those are some workshops that we plan to host in the next quarter. So yeah, definitely look out for those. And this is also our last workshop for this quarter. So thank you for coming. And I really am like thankful for all the staff that have made this workshop series possible. So yeah, thank you.